experience as the project engineer. That is why I managed to get the IR qualification. Okay, so the book that we're going to use as our first reference is this book. This is the writer is a Potter. Okay, Mechanic of Fluid. I believe I have posted in the WhatsApp group. Okay, so it's okay. I will post again in the e-learning. Because this book we're going to use throughout the semester. Okay, so before we start our session, I would like to share with you the course introduction, course information. Okay, this is very important. Okay, can you see this one?
Yes, Doctor.
Yes, Doctor.
Okay, the course information is very compulsory to be explained at the beginning of the class, the first class, all right? So this is the course information. The code for your course is SEMM2313. The prerequisite is this subject, all right? So this is the course synopsis. The principal aim of this course to provide the student with the understanding of the property of the fluid. Okay, and this is my name. I'm the coordinator for this subject. Okay, and we have another 3 lecturer. This is my name. This is my contact detail. If you have any question, you can email me. You want to contact me directly. And the other lecturer, Dr. Umi, Dr. Muhammad Afiq, and Encik Muhammad Zubil. Right. So we have one PLO, program learning outcome, and 4 course learning outcome. All right. So this is the course learning outcome we map with the program outcome. Right. So the course learning outcome number 1 that we need to achieve throughout this semester, the first, calculate and analyze the shear stress in the fluid, the pressure difference in manometer, hydrostatic forces on plane and curved surfaces, as well as you need to learn the buoyancy force, stability of a submerged floating body. So the first semester, we're gonna learn about CLO1. Okay, analyze the shear stress in the fluid. After that, you need to go to the CLO number 2, which is course learning outcome, to calculate, analyze the fluid dynamic. All right, the first is the fluid static. The second one, the fluid dynamic. The CLO number 3, you need to understand the major and the minor losses in a pipe system. And number 4, you need to understand the dimensionless parameter that contribute to the dimensionless analysis and similitude study. All right. So CLO1 until CLO4 will contribute to the PO1, which is program outcome number 1. This is program outcome number 1. All right. So all these 4 going to contribute to PO1. Okay. So this is very important. I want you to take note. The first week, right? You can see week 1, we start at 14th of March until 18th of March. I'm going to brief you the overview of the course. All right, that is mean the course information. All right, and then the introduction of fluid mechanics. You're going to understand the basic definition of fluids, the dimensions, the unit, and finally the fluid property. And week number 2, fluid property, and as well as fluid static. So we're gonna have here week 1, we're gonna study here. Week 2, week 3, week 4, 5, 6, and 7. After that, semester break, and we shall continue until week 15. So this is I have set the test date. This is you gonna have the two tests. All right, test number one gonna be 23 April 2021 on Friday at 9 to 11 a.m. This is just my expectation. Okay, and then test number two on June 11 June Friday 9 to 11 a.m. in the morning for the Malaysia time. And finally, your revision week 16th. Okay, this is your assignment that you need to fulfill in order to score well in this subject. All right. The first is assignment. You're gonna have one assignment to be assigned by you, and this is contribute to PLO1. The percentage of the assignment, all right, is 10%. That means I'm going to give you some assignment throughout this semester, and I'm going to choose which assignment that you score well, and I can use that score to be my record. All right. And secondly, I'm going to give you the programming assignment. Later on, I'm going to explain to you. This is about using the C++ language or MATLAB or whatever code that you know. This contribute 10%. And this is very important. We have test 1 contribute 20%, test 2 20%. Okay. The test duration 1 hour and 15 minutes for both tests. Okay. And the final examination is 40%. So total here 40 plus 20, 20, you have 80%. So the assignment and programming assignment going to contribute 20% of your total mark. Okay. So do you have any questions so far?
Yes, doctor. The programming assignment.
Okay. For the programming assignment, I'm going to give you.
How simple is it?
First, you need to understand the chapter that you're going to learn. For example, you learn about the buoyancy. And then I give you the task, the case study. For example, the company of ABC Sendirian Berhad would like to hire you to solve the fluid mechanic issue by programming the code. So that means it is like a calculator. You input the value and finally you're going to have the output. It's something like that. Okay, all right. Okay, so this is our reference textbook. Okay, Potter. Okay, this is very important. Academic honesty. Okay, whatever you do, please do not copy and paste. All right, please do not cheat during exam. This is very important because we, as a lecturer, if you try to copy and paste other friend, we know that your solution gonna have the same with your friend. Okay, we're gonna check one by one, and if this happen, we're gonna put your mark as the TS, right? It is investigating process. So I really hope that all of you here, please follow the academic honesty, okay? Because we're gonna check everything of your answer, so that you won't copy and paste from others. Okay, I think that's all about the course information that I have highlighted to you about the academic honesty, the assignment that you're gonna conduct during the semester, okay, the score that you need to do well, as well as the subject that you're going to learn. week by week. So this is CLO1 until CLO4. Okay, so far do you have any question? Sure, doctor, but please make the exam as simple as possible, not so complicated. Sure, if you follow my method, that shall be no problem because I'm going to guide you step by step throughout the fluid mechanic journey. Okay, do you have any question? Okay, thank you. Okay, if you have any question, please comment there. I will entertain all your comment. The test, for the test, it is expected to be online, all right? But our management try to make it offline, okay? Because we want to avoid the uh, cheating during the exam. So our management currently working to work on the offline exam as well as the final examination. Okay, so in the meantime, I'm expecting it's gonna be the online session for the exam. Okay, what about the notes? The notes gonna be shared with you in the PDF file through the e-learning. All right. So I hope that you access the e-learning because I'm going to upload the the PDF file, the notes, as well as the video recording for today's session. Okay, Doctor, can you please share the attendance again? Okay, I'm going to share the attendance at the end of the class. Okay. Okay. Thank you so much. Okay. So let me start. Okay. So this is my profile. Okay. So may I know what is fluids? Can you comment there? Have you ever heard what is fluids? Okay, doctor, why is it that most people are scared of fluid mechanics? Because when they scared the fluid mechanic, they have trouble to understand the fluid mechanic. And when they have trouble to understand, definitely they won't be able to score the subject. So I hope that you remove your stigma, negative stigma of the fluid mechanic, and please understand, please make it as your friend, all right? Okay, can you share the book? Sure, I can share the book in the e-learning, all right? So after this session, I'm going to share. Don't worry. Okay, so anyone please answer what is fluids? Since you are going to learn the fluid mechanic, all right? So what is fluids? Substance. Najmul said substance with no fixed shapes. Okay, that is correct. What is the base of fluids? Yes, that is the example of fluid. Liquid and air call a fluid. Okay, something to do with the liquid. Okay, I want everyone to participate. If you participate in the session, you're going to make this session very interesting later on. Okay, Muhammad Hasibul, flow. Any substance that have the fluid property. Okay, anyone? What do you know about fluids? Can you see the picture here? This represents the water splashing. All right. So the water, the phase of matter of which include liquid and gas. Okay. So the liquid and the gases are the fluids. You need to understand why. Because this is the reasons. A fluid is a substance that continuously deform under an applied shear stress or external force. What it means by if you try to push, you try to have the disturbance on the water, the substance of the water will move, will deform under your apply external forces. Okay, so you need to understand the fluid is a substance that continuously deform under your apply shear stress. Okay, for example, this is the solid, the phone. When you apply the external force, okay, doctor, shear stress is it the same as the solid? Okay, shear stress can be applied for solid, can be applied for the fluid, because this is the shear stress. The direction in this lateral direction we call as the shear stress. Okay, for example, this is solid. Or okay, this is calculator. Calculator definitely solid. You try to push, you try to have a disturbance, external force. Do this particle move, deform continuously? Anyone? When you try to move, you try to push. No, because this is solid. The particle will not deform, so we call it is not a fluid. Right? So for example, we have the water. Okay, inside the water, we try to have the external force and the water will deform continuously. That is why we call as the fluid. So that is why the liquid water, when you try to impose the external force, the water or the gas, it will deform continuously. All the matter that deform continuously with your external force, we call as the fluids. Okay, so now you understand, yeah, what is fluids. Okay. Alhamdulillah. All right. So next is, what does fluid affect our life? Can anyone here comment? What does the fluid affect our life? Can you give example or application? What the fluid in our surrounding affect our life? Okay, I cannot understand. Ibrahim, can you write in? Okay, what's does the fluid affect our life? Can you give example? I give you one example. Like our, yes, water in a pipe. Okay, that is correct. Exactly, because the water move throughout inside the pipe. Okay. For example, our body, we have the blood circulation. So the bloods, the flow of blood we call is the application of fluid mechanic. All right, because the blood have to move through entire of our body. Okay, through flowing of the blood, okay, the blood will exert the resistance from the wall of our veins. It is considered as 73% of our body weight. Okay, that is a water, blood from the water. Okay, the blood circulation, the air we inhale, exhale. So all these, the move of the fluid we call directly related to the fluid mechanic. Okay. So for example, human body, blood flow, you can see the red oxygenated blood and the blue deoxygenated blood. And our home, water pipe, HVAC, heating, ventilation, air conditioning system. All right, I believe many of you have the aircon system. Okay, fluid movement in the aircon pipe AC is very important. Yes, very important. That is why you need to learn the fluid mechanic to understand better how the fluid flow interaction from the surrounding to the internal, the car, the airplane, the external of air coming to the car, how to reduce the drag force. So all the engineer or the automotive engineer need to understand how to reduce the drag coefficients of the car. The airplane, how the airplane move. We have the lift force, we have the drag force, all these from the fluid mechanic. Okay, wind turbine, how we extract the energy from the wind. We introduce the turbine, how the turbine rotates because of the drag force coming from the wind. So because of the fluid surrounding us, we can utilize the fluid flow for our future. Okay, for our comfortness. That is very important. You need to learn the fluid mechanics subject. So I hope that every one of you here don't be negative skeptical about the fluid mechanic. It is very easy. Okay, if you focus in my class, right? So that is a very simple. If you can focus in my class, you keep participate, active, do the revision as my advice. This gonna help you a lot in your final exam as well as in your test. Okay. So next, after you know the importance of fluid mechanic, here is the basic fundamental of the dimension. Okay. Next, we're gonna learn about dimension, unit, and physical quantity. So, the fundamental dimension, the 9 quantities that can be expressed all other quantity. All right, this is a fundamental, or we call as the base dimension. The length, all right, the mass, the time, the temperature, amounts of substance, electric current, luminous intensity, the plane angle, the solid angle. All this is the fundamental dimension. Okay, this fundamental dimension or the base dimension can form the derived dimension by combinations of the fundamental dimension. For example, velocity. What is the unit of velocity? Anyone? What's the unit of velocity? Yes, meter per second. So you can see meter, length, second, time. The combination of fundamental quantity will form the derived quantity. Derived quantity is like the acceleration, velocity, all these we call a derived quantity. So the derived quantity taken from the fundamental dimension. So this is the fundamental you need to understand. Okay, basically all these dimension can be categorized into two primary system: the English unit and the SI unit. Okay, the SI unit is normally we use in our course. For example, like you mentioned, meter per second. It is SI unit, system of international unit, international units. All right. So, for example, the length, the dimension is L. For those don't understand what is dimension, the dimension is referred to the degree of the quantity. Okay, that is the definition of dimension. So the length here, the SI unit is meter. For the English unit is foot. All right. For the mass, it is kilogram. For the English, it is slug, and so on. However, for the time, it is the same. Second and second. Okay. Temperature, you have the Kelvin. and you have the Rankine. Okay, Kelvin and Rankine. Okay, this is the derived quantity as I mentioned before. The combination of fundamental quantity to form the different parameter, like you have given to me the velocity meter per second, acceleration meter per second squared. So all this is the derived quantity. Can you see here the area? The dimension is the degree. You can see the power of 2. L squared. So the unit is meter squared. So please bear in mind that throughout the course, normally we're going to use the SI unit. Otherwise, if explained, if given the English unit, you need to use that. All right. All this is the derived unit. For example, like density, specific weight, surface tension, the energy, all this is the derived unit. Okay. You can convert. Okay. That should be no problem. Okay. This is the multiplication factor. All right. I believe you know this one. Okay. Like tera, 10 the power of 12. This is symbol T. Giga, 10 the power of 9. Giga. And mega, 10 the power of 6. Kilo, 10 the power of 3. Why you need to learn this prefix? Because later on, the question gonna give you the prefix and you yourself need to convert the prefix into the SI unit. Okay? So they give you, for example, the milli. You need to understand the milli refer to 10 the power of negative 3. Alright? So the symbol, the small m, right? The micro. This is the symbol. Nano 10 the power of negative 9. Okay, so far do you have any question? I believe you understand, yeah? The definitions of fluid mechanic, the dimension, the fundamental, and the derived quantity. Okay, thank you. I want your response so that this session gonna be interesting and meaningful for you to learn. Okay. 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 Continuum view of gases and liquid. Okay. So, what do you understand about continuum? Can you comment there? What do you understand about continuum? What is continuum? Okay. What do you know about continuum? I give you 2 minutes to think. What do you understand about continuum? Because later on, I'm going to give you example of continuum. This is very important for your basic understanding of fluid. Okay. Molecular study of fluids. Okay. Almost correct. Not finished. Continue. Okay. A distributions of substance. Okay, good. Okay, basically continuum is actually, wait, yeah. Okay. Okay. So someone said don't stop. Similarity, distribute of substance. All of you correct. Okay. Basically, the continuum is actually the continuous of the molecule. Continuous means, okay, let me explain clearly. Okay. This is the molecule. We focus inside the box. Okay. Okay, sorry. Okay. Okay, sorry. Okay, for example, this is molecule. Alright. This molecule is close together continuously. Okay, between this is close together. This we call as the continuum of liquid and gases. Okay. What happen if the liquid here or the gas in this way? This is not we call as the continuum. It is not close together. How do you define the close? Later on, I will explain. So before that, you need to understand. The continuum means the distance between the particle to particle is very close to each other. For example, this is water. Okay, this is water. Okay, this is water. Do you think the water is continuous in nature? Anyone?
Yes.
Yes.
The water is continuum in nature? Yes. Inside the pipe, the water is continuum in nature. This can be proved if you try to cut the water. If you cut the water, what happens? You cut the water. Is it going to continuum again?
Yes, of course.
Yes.
Yes. That is why we call as a continuum. The particle of water with other water molecule is very close. Even you cut, it try to connect back together. Okay, we call as a continuum process. For example, the gas. Okay, this is the gas. Okay. What happens if you try to cut the gas? What happened to the particle?
Return to be a continuum.
It can be the continuum. Okay, because the particle close to each other. So, how to define the distance of continuum process? Okay. Wait, yeah. Okay, a substance can be both liquid or gases. Liquid, a matter in which molecules are relatively free to change their position with respect to each other. Molecules are restricted by cohesive force. The gas, matter in which the molecules are unrestricted by cohesive force. Okay, this is the definition of substance. Okay, this is very important. The continuum model, when we define whether it is continuum or not, we define by the continuum model. Continuum model can be checked by accuracy by comparing the characteristic length with the mean path, with the mean free path. Okay? If the characteristic length is more than the mean free path, we call as a lambda. Alright. Alright, so this mean free path we consider as a lambda. Okay. If the characteristic length is bigger and bigger than lambda, which is mean free path, the continuum model is acceptable. Okay, what is the mean free path? Average distance a molecule travel before it collide with each other. Okay, for example, this is the molecule. I believe this is water. I consider like this because we know water H2O. Okay, hydrogen and oxygen. So I just draw like this. This is water. Okay, this is the molecule of water. Alright. So the characteristic length here we refer here. Okay, we refer as the characteristic length with the mean free path. Mean free path is the average distance a molecule travel before it collide. So that means from here to here, we call as a lambda. This is we call as the L. So far you guys understand what is the characteristic length and the mean free path? Okay, so it means that if the L characteristic length is far bigger than the lambda here, we call as the continuum process. I give you two cases to understand. Okay, this is the L is bigger and bigger than lambda. This is the case. Okay, where is the L? This is the L. Where is the lambda? This is lambda. Is it clear? Lambda is bigger. The L is far bigger than lambda. You can see the particle are packed together, close to each other. Okay, this is the case where the L is less and less than lambda. Okay, where is the lambda? This is lambda. And where is the L? What do you notice here? What is the difference?
The distance very big, I think.
Okay, can you see I try to make it the box? Okay, which one is continuum? Left or right?
Left.
Left.
Left. Why it is left? Why the left is continuum?
Because it's very
Because
close.
DL is bigger than lambda.
Yes, bigger than lambda. And if you can see here, the particles are closely packed to each other, right? It is closing.
Closing,
For
yes.
this case, the lambda is the L is very small than lambda. You can see the particles are far away. Is this considered as continuous? This is not continuous,
Not
alright?
continuous.
Okay, so you guys, every one of you understand what is continuum and what is not continuum. Okay.
Yes.
Okay, so that is how we check whether the molecule is continuum or not. If L characteristic length is far more than lambda, the continuum model is accepted. Okay, Ibrahim, can you again? What do you mean? Do you understand? Okay. Okay. This is the equation. Okay. The lambda. Okay. Ibrahim do not understand. Okay, Ibrahim, which part you want not understand? This one or the equation? The last one, is it the equation? The equation. Okay. So this is the equation, okay, given by the researcher to predict the relationship between the lambda and the characteristic length. Okay. So this is lambda. This we call as the continuum model. If this is continuum model, then you have to use this equation, lambda equal to 0.225 m mass over density diameter squared. Okay, this is actually the formula if that is considered as the continuum model. If that don't consider as the continuum model, you cannot use this equation. Okay, that is very simple basically. But you need to understand this one. When L is far bigger than the lambda, it is continuum. When it is continuum, you can use this equation to find the, for example, the question give you, what is the lambda when the question give you the property of the substance or the molecule, the mass, the density, the diameter. Okay. Okay, this is the pressure. I believe you understand what is pressure. Pressure is the force over area. It's very simple. The absolute pressure is zero, is reached for an ideal vacuum. Okay. So this is basically the definition between the absolute, the atmospheric, and the gauge pressure. Okay. So I believe this is very important because you need to understand the pressure category. We have the absolute pressure. That means the absolute, we start from the ground. We start from the zero reference. The gauge pressure is meant by, we start from the atmospheric pressure. Okay. So this is the equation, P absolute. If you want to calculate the absolute pressure, you have to plus the atmospheric pressure plus the gauge pressure. The gauge pressure is the pressure for that particular molecule or that particular substance. The atmospheric pressure, what is the value of the atmospheric pressure? Anyone here knows? What is the value of atmospheric pressure? Can you give me the answer? Okay, 10135 kilopascal. All right. That is the at the point of our reference. For example, at zero, at the zero height. What happened? Do you think the atmospheric pressure will change with distance or with height if we at the mountain? Is the atmospheric same or different?
Different.
Yes, it's gonna be different, all right? Different elevation will have different atmospheric pressure. How to know that value? Please refer to the appendix of the textbook, all right? In the appendix section, they give you different elevation. For example, 2 kilometer, 3 kilometer will have different atmospheric pressure, okay? Okay, this is the temperature. I believe you understand. This is how the conversion happen. Normally, we use the Kelvin, all right, as our SI unit. Kelvin is equal to Celsius plus 273.15. This is how we convert the Kelvin. This temperature scale is the absolute temperature. Kelvin is the absolute temperature. The Celsius is the ordinary temperature. What is the difference between the absolute temperature and the ordinary temperature? The ordinary temperature like we feel now, 15, 18, 20 degrees Celsius. For the absolute, we use the Kelvin. What's the difference between the absolute and the Celsius? Absolute and the ordinary temperature. Anyone knows what's the difference between the absolutes and the ordinary temperature? Yes, correct, Ahmad. Substance does not move at the absolute temperature. Okay. So when we consider as the absolutes, this is absolute in the SI unit. This is absolute in the English unit ranking. All right. This absolute means the substance will never move at all. We call as the absolute. The substance particle, this is particle. You know the particle will vibrate, will rotate, will move. Okay, when considered as the absolute, we refer, okay, we make comparison the temperature now with the temperature of the absolute. Substance does not move. Okay, this is what we call the absolute temperature. The substance does not move. That means the temperature that we refer is relative to the substance do not move. Okay, that's we call as absolute temperature. Okay, this is the specific weight. Okay, what is specific weight? Specific weight is the weight per unit volume. So how to define as the equation? Okay, specific weight, the symbol is this one. Okay, this is specific weight. The specific weight is the weight per unit volume. So weight, what is weight? Weight is the mass multiplied with gravity over volume. You know that the mass divided with volume, we got the density. That is why density multiplied with gravity is actually the specific weight, gamma. So far you guys understand, every one of you, what is a specific weight?
Yes, Dr. Yes.
Okay. On the other hand, the specific gravity is the ratio of the density substance to the density of water. Okay, the symbol normally as Gs is equal to the density of the substance divided with density of the water, or the gamma specific weight of the substance over specific weight of the water. I believe you know, yeah, what is the density of the water at room temperature is 1000. This is standard. Okay. Okay. So what is the specific weight of the water? Anyone knows? What is the specific weight of the water? Can you see? This is specific weight is the rho g. Rho of the water, density of the water is 1000. Multiply with gravity 9.81. So you're gonna add, you're gonna have 9810. This value refer to the specific weight of the water. Okay. Okay, I think that's all for today. Later on, we're gonna continue on the fluid property. So far, do you have any question before we end our session today?
No, thank you, Doctor.
Okay, welcome. Okay, now I share you the attendance again. Please scan the QR code because at the end of the course, I'm gonna record and share this attendance to my management. Okay, for those who are unable to be in my class, your name will be appear, not in the listed here. So it's very important. Okay, it's okay. I will share the note through the WhatsApp. Okay, now we have 24 persons only. In the course registered, it is 44. Why at 4 degrees Celsius? I'm not understand, Najmo. Why at 4 degree? What do you mean by 4 degree? Okay, I think I will explain to you the next session. Okay, this is actually the example. The one with the specific gravity. Oh, the ratio density of the substance to density of the at 4 degrees Celsius. Okay, this is actually the example. Okay, the ratio, the density of the substance to the density of the water at 4 degrees Celsius. Basically, this is typo. Okay, I will revise later on. Okay. Okay, please scan first. Thank you, Najmul, for noticing that. Okay. Basically, the specific gravity can have at any temperature. It is not necessary 4 degrees Celsius. Okay, I believe that's all for today. I really hope that you keep your momentum to study before the class, all right? Because this subject is a core subject. So I think that's all for today. Doctor, I cannot scan the attendance because my phone is broken. Okay, I will share the I will share the QR code through the WhatsApp, yeah, after this. Okay. Is it okay, Shahda Aulia? Okay. Okay, I think that's all. Thank you very much for your time. I end my class with Assalamualaikum warahmatullahi wabarakatuh.